In this video, we'll fully connect our HV to LV DC converter to the system, start it, and perform the first power conversion. You'll also learn how to adjust settings dynamically using the CAN connection. Let's get started. For this tutorial, we'll use our DCDC MP with dual LV ports in the liquid-cooled configuration. However, the same steps apply to all our HV to LV models, including all our SP and LP models. In our previous tutorial, we connected the converter to the computer using the peak probe and configured the settings through the CAN communication. If you haven't seen it yet, you'll find the link in the video description. Now let's connect the converter to the system. To simulate our setup, we're using a dedicated power supply and a load. On our HV to LV models, the main power supply is provided from the LV side. To verify that the conversion is working properly, we'll also connect measurement instruments. If your product features a liquid cooling system, make sure it is connected to your cooling circuit. Depending on your system architecture and voltage range, you may need to ensure proper pre-charge of the circuit. This is especially important when connecting a battery or when the bus voltage is above 20 volts. Once everything is properly connected and the initial parameters have been entered using the CAN loader, we can start the power conversion. At this stage, it's important to make sure the control system and the converter communicate correctly. In this case, in order to simulate the control signals usually provided by an ECU, we use a dedicated application. Start the external low-voltage power supply and send the enable message. As you can see, the product reads the supply voltage on LV port 1, but there is no power conversion yet. On the HV side, we are also connected to a 600-volt source. First, let's perform a power conversion from HV to LV. Use your control unit to send a power on message. To start the power conversion, send the out1 requested and out2 requested messages. The power conversion starts. We now have LV1 at 48 volts and LV2 at 24 volts. To stop the power conversion, clear the out1 requested, out2 requested, and power on in the control message. Now let's perform a regeneration conversion from LV to HV. Our LV2 source is set to 24 volts, and our HV set point is set to 500 volts. Notice that in this case, since power flows from LV to HV, the current set point is negative. Send the region on message, send the out2 requested message. The power conversion starts. You can easily adjust the HV voltage by sending a new set point through the CAN bus. Here we adjust the output to 600 volts, update, and the port voltage reaches the target value instantaneously. Finally, let's operate in umbilical mode. In this case, the source is LV2. Once again, because power flows from LV2 to LV1, the current set point on LV2 is negative. Send the umbilical on message. Send the out1 requested message. The power conversion starts. You can easily adjust the LV1 voltage by sending a new set point through the CAN bus. In this example, we seamlessly move from 48 volts to 14 volts with a constant source at 24 volts. To stop the power conversion, clear the out1 requested and umbilical on in the control message. If you disable the wake-up signal, the product shuts down. You can now switch off the power supply to the DCDC converter. For more information, please refer to the user manual provided. The user manual, along with all necessary documents and files, can be found either on the USB drive included with the unit or on our online portal. If you are unsure about any of these settings, don't hesitate to contact us.